So example number 1, determine the deflection 2 meters from the right support. So before kuhaon ang reaction, all we have to remember is first get the estimated deflection or elastic curve and place the point which deflection is asked. In this case, it's at 2 meters here. This is the deflection being asked. Therefore, we're going to place the P force here. So I assumed that the deflection is downward based on the elastic curve that I have shown. So therefore, the vertical force is directed downward. So that's P. And in this case, we are now going to write the letters to every change of loading together with P and the supports. We have A, B, C here, and then D. This time we have 3 segments. And of course, since we now have the P force together with the existing force, we are going to solve the value of the reaction at A in terms of P together with the reaction at D in terms of P. So let us solve for the reaction. So we're gonna have the summation of moment about point D so that we can solve RA. So you have RA times 6 equal to 40 times 4 and then plus the P. Of course, this is 2 meters, right? So that's times 2 meters, or that's times 2. So therefore, RA now is equal to 160 plus 2P over 6. So that's going to be 160 divided by 6. That's 80 over 30. So RA is 80 over 3 plus P over 3. So that is the value of our RA. And in this case, we're going to solve for RD. So summation of moment about point A. So we can solve for the reaction at D. So all we have here is RD times 6 equal to 40 times 2 and then plus P times 4. So RD here is now equal to 80 plus 4P over 6, or RD is 80 over 6. We have 40 over 3 and 2/3 of P. So if we try to check whether our reactions are correct, then we can have the checking summation of forces vertical, just in case you don't really, or you're not really sure, but having this reaction not correct will really not give you the correct values of your deflection and slope. So you just have to make sure that all your actions are correct. So you have RA plus RD, and that's equal to 40 plus P. So let's just check. It's 80 over 3 plus P over 3 equal plus for the RD, it's 40 over 3 plus 2/3 of P equal to 40 and P. So if you try to add 80 over 3 and 40 over 3, it's 40. So it's 40, then plus 1/3 plus 2/3, it's P, and that is equal to 40 plus P. So we got it correctly. So this time, since we have validated that our reactions are correct, so we can now proceed in getting the segment. So we're gonna cut the beam or the segments AB. So basically we're just going to follow what we did from the virtual work method. So but in this case, it's a shortcut method where you don't have to draw another virtual beam anymore. Instead of placing the P immediately at the point where deflection is asked. So segment AB, and then what we're gonna do here is we're gonna draw the beam or the segment or the section rather. So say this is the section, and then I'll place here the reaction RA, and at the point of cutting, of course, the same gihapon gonna have M, and then this will be Rx. So this time we're now ready to solve for the moment equation. Summation of moment at the point of cutting here, that's the point of cutting, equal to 0. You will have M equal to RA times X. And since M, or RA rather, is 80 over 3 plus P over 3, so you have to substitute that. So it's 80 over 3 plus P over 3. And of course, you still have that X. This time, we have to substitute. It's 80 over 3x plus P over 3x. Here, we're now going to get the partial derivative of M with respect to P. So it's partial derivative of M with respect to P. So we're going to set the values with no P equal to 0. Okay, so imaginatively. So we're gonna set this term here into 0 because that is partial differentiation. So it's going to be considered as the constant. So the constant, the derivative of the constant is 0. And then here, this will now be considered as with the variable, since the variable now is P. So in this case, the differential or the derivative of 1/3 x of P is equal to the 1/3 of x. So this time, we can now create the product of M and the partial derivative of M with respect to P equal to 80 over 3x plus P over 3x times you have the 1/3 of x. In this case, the last procedure, we're going to set all the terms with P equal to 0 there. So finally, the equation of the product of M and the partial derivative of M with respect to P is now equal to 80 over 3x times the 1/3 of x. This is for segment AB. Do not forget this. So let us proceed with the next segment. So in this case, I will be cutting this portion and consider the left section. So proceed though with the segment. So I'll just rewrite here the segment BC, and we're gonna draw the segment so here I'll just draw the segment, and then I'll place here the reaction RA, and of course we have the 40 here, and of course this is your point A, this is your point B. In between the 2 points is now ato siya ibalik to 2 meters, and then from here padung sa point of cutting, it's now X. And then of course I'll just place the m here. In this case, we are now going to get the equation, moment equation, equal to 0 at the point of cutting. So you will have m equal to RA times x plus 2 and then minus 40 times x. So let us substitute the value of RA, which is equal to 80 over 3 plus p over 3x times x plus 2 and then minus 40x. In this case, we are going to multiply this whole term or distribute that whole term, this, to each term here. So it's going to be 80 over 3 times x plus 2 plus p over 3 x times x plus 2 and then minus 40x. So this time, we are now going to get the partial derivative of m with respect to p. So again, all the terms without p is set to 0. And then this term here, get the derivative. It's going to be, it's 1/3 of x times x plus 2. Or, kung ganahan ka, imo pa na siyang i-simplify, it's going to be 1/3 x squared plus 2/3 x. That is your partial derivative of m with respect to p. And in this case, let's get its product. The m times the product, the partial derivative of this segment, which is 80 over 3 x plus 2 and then plus p over 3x times x plus 2 minus 40x to be multiplied by this one, 1/3 x squared plus 2 over 3x. So in this case, the final term now, since with the p, we're going to set that to 0, it's going to be now, therefore, it's m times the partial derivative of m with respect to p equal to the product of 80 over 3 x plus 2 minus 40x times the 1/3 x squared plus 2/3 x. So that is your term. So ato lang siyang pagamyan kay murag dako-dako kay siya. Okay. Next is, let us proceed with the last segment. For the last segment, so it's all up to you whether you're gonna cut here and consider that, or para simpler lang ang figure, it's going to be cutting here and consider the right side. So in that case, I need this type of section, and then I'll place here segment CD. And with this, I can now paste here. And we're going to place the reaction RD, since this is point D now, and this is X, and we have here the moment, since this is the point of cutting. This time, as you observe, walay labot ang P, of course. P is not part of the section, since we cut through only between C to D, not exactly at C. Okay, so we now have the we can now create the moment equation at the point of cutting equal to 0. It's m equal to rd times x, where rd is equal to 40 over 3 plus 2/3 of p times x. So it's going to be now 40 over 3x plus 2/3 of px. So to get the partial derivative of this equation, all we have to do is set this one to 0 first, and then only this you're going to differentiate. So it's going to be 2/3 of x. And now we are going to get the product of the partial derivative of m with respect to p. It is now 40 over 3, although nakaset to 0 na siya, but again, I just place it, or I just set it to 0 for a period of time. But the moment nga you're going to write this one, you have to copy that. Okay, so that's 40 over 3x, and then plus the 2/3 px. So that's the m times 2/3 of x, for that is the partial derivative. So here we're going to set now all the terms with p equal to 0 there. So that's the final equation. So the product now, the final product of the m times the partial derivative of m with respect to p is equal to 40 over 3x times 2/3 of x. That is your equation. So this time, let us now get the integral. So since we're talking about deflection and we assume that the deflection is downward, it's actually the 1 over ei of the whole integral. So integral of m times the partial derivative of m with respect to p dx. This is for AB. So since AB man na siya, the limits is the length of AB. So what is the length of AB? 2 meters. So the limit will be from 0 to 2. Next, we're gonna add the integral of the next segment dx from B to C. So the length for B to C, as you observe, B to C, it's 2 meters. So the limit is from 0 to 2. Next, plus the integral of the next term, m times m dx, and this is for C to D. And the limit, of course, the length of C to D. What is the length of C to D? It's 2 meters. So it's from 0 to 2. So this time, we are now going to get the equation done. So it's 1 over ei times the integral. So first equation, it's here. So copy this one, copy this, and so I'll just erase this portion. And this is dx, limit from 0 to 2, plus the integral so of the next segment. What is the next segment? Here, this one. This is the length, the integral of the next segment. And let's paste it here. And this is dx, limits from 0 to 2. And for the last one, plus, so same integral So copy this, for this is the last segment, and paste it here. So the limit, or dx rather, so I'm sorry, it's dx by di from 0 to 2. Okay, so we have 1 over ei times, let's first proceed with this one. So it's going to be the integral of 80 over 3 x times x over 3 from 0 to 2. So it's 640 over 27 plus this one, this term. It's going to be 80 over 3 times x plus 2. So it's better not to distribute the x plus 2 para at least dili mo magkataas ang inyong term. Kaya na dyan siya possibility that you might get mistakes along the process. And then you multiply the next term, 1/3 of x. Wait, what happened? 1/3 of x square, and then plus the 2/3 of x, and the limit is from 0 to 2. So the answer here is 2080 over 27 plus the last segment here. So integral of 40 over 3 times x multiplied by 2/3 x, and the limit is from 0 to 2. So it's 640 over 27. Okay, so let us now get the answer. So the deflection is equal to 1 over ei times, it's 640 over 27 plus 2080 over 27 plus 640 over 27. So that is 1120 over 9. The unit here is kilonewtons cubic meter. And this is our final answer. Uy, ano naman na siya? And this is the deflection 2 meters from the right support. That's example number 1.